So, equivalent fractions. These are fractions that represent the same part of the whole. Meaning, so it's going to be a different number on bottom, which is a different size of piece, and then we will have a different number of copies. But what this means is that some of these copies for the fraction that has the bigger denominator, which means smaller pieces, I can merge some of those pieces and get a fraction written in terms of a larger a smaller denominator, which is a larger size piece of the whole. So we're looking at 5/8 versus 15/24. So I can take a circle, cut it into eighths, and then I'm counting 5 of those copies. Or I could take the same circle, cut it into 24ths. Or if you want, you can think of a rectangle and take 15 of those. And the question is, if my whole is the same, are these two fractions going to take the same part of the cake or the pizza or the pie away? So a couple of ways to do that, but the big one is, what is the one number we can multiply by, and our result is the same as what we started with? So I'm asking, what is, 74 times what will equal 74? There's only one number, and it is 1. Now here's the tricky part. Mathematics, one of the crazy things we will do, and it will make strange stuff happen, is multiply by a crazy form of 1. So in this case, I'm trying to figure out, can I rewrite 5/8 so that the denominator is 24 instead? Is there a nice whole number over itself, a crazy form of 1 that I can multiply by so that 8 becomes 24? So hopefully when you're looking at this, you're kind of remembering, okay, 24, 8 does go in there. It does. It goes in there 3 times. So if I take my 5/8 and I multiply by, I'm going to kind of put in quotes up here, the number 1. But what we're going to write instead of the number 1 is 3/3. And I know we haven't talked about multiplying fractions, like I'm doing this out of order. It's just, to me, all of that knowledge is kind of in a big ball together, so I pull it out as it's useful. I think the way the book and thus an explanation on Alex, they would write like, well, 8 times 3 is 24, so is 5 times 3 15. And 5 times 3 is 15, so we'd say, yes, these are equivalent. And that works, but it's kind of, I don't know. I like talking about this crazy form of 1. This is a tool you use a lot more often. This is just a place where it works, but there are other ways to do it. So the times 3 is not wrong. That is literally what we're about to calculate. So multiply the tops. 5 times 3 is 15. 8 times 3 is 24. All I did was take 5/8 and multiply by a ridiculous 1. So this end fraction I got, which looks different, is still the same as 5/8 because what I multiplied by didn't change the value. It didn't make it bigger. It didn't make it smaller. It just made it weirder. Now from a, what the heck did I just do to my cake or my pie? So I had my pie cut into eighths, and I took each one of those pieces and cut them into 3 pieces. So instead of eighths, if I take 1/8 and I slice it into 3 pieces, and I do that for all 8 of the pieces, I would now have 8 times 3, 24 equal pieces. And then for each of the 5/8, I've now have 3 for each of those, 3 24ths. So that's 15 of the 24ths for the same 5/8. Now, same thing with the 2/3 and the 18 21sts. So 18 21sts is definitely not what we call lowest terms. Those two have a number in common they can be divided by. But here, when we're going to look at this, are they equivalent? A lot of times this question is actually ninja'd in with which fraction's bigger, which does require thinking a bit more about it. And for me, if I'm going to answer which fraction's bigger, I like the bottoms to be the same. So I know I'm talking about the same size slice of pizza, because my brain hurts if they're different size slices and I got to figure out which one's bigger or smaller. Everything goes backwards. If the bottoms are the same, then I'm just talking about numbers of copies, and that's straight bigger numbers, bigger fraction. So to turn 2/3 into something with a 21 on the bottom, which is the same way I started this one over here, because that's what these questions usually are. It's which one is bigger. So to get to 21, I would multiply by 7. So I want to know 2/3 is the same as what number over 21? So 2/3 times the crazy form of 1, 7 over 7. Which, let me sketch that in. And multiplication is the same one way or the other, so I can write 7 over 7 in front of the 2/3. But on the bottom, 7 times 3 is 21. On the top, 7 times 2 is 14. So is 14 21sts, which is the same as 2/3, is 14 21sts equivalent, the same as 18 21sts? 14 copies, 18 copies. Which would you rather have if we're talking about cake or pie and you like sugary things? You want 14 21sts or 18 21sts? 18 is more pieces. They're all skinny pieces, but it's still more pieces. So 18 21sts is bigger than 2/3 because it is bigger than 14 copies of a 21st size piece. But in this case, are they equivalent? We would just answer no. But if it was a different question where they asked which one's bigger, we would say the 18 over 21 is bigger. Now, another thing you can do is crunch the numbers on the calculator and figure out what the decimal approximation is. Because the decimal approximation is the same for equivalent fractions and is different for fractions that are not equivalent. And most people find it easier to compare the decimals. We're going to talk about decimals in 2 sections. So if you wanted to go watch that and then come back, that is totally fine. I try to label the videos so you guys can move all around whichever way you want. So simplifying fractions to lowest terms. A fraction is said to be in lowest terms, reduced or simplified, when the numerator and denominator share no common factors other than 1. So that is a really long way in math. We shortened that idea to what's called relatively prime, meaning the two numbers share no factors. So one to the other, they are prime. So it might be like 4 and 9. 4 is not prime. 9 is not prime, but 4 and 9 share no common factors. So 4/9 or 9/4 are both reduced. But if I had 4/18, different story. So this is another place where knowing those divisibility rules can come into play, because you're asking yourself, okay, the top is even, is the bottom even? Can I divide them both by 2? You don't have to come up with the magical C, the largest common factor or the greatest common factor. To reduce fractions, you just have to come up with a common factor, pull it out of the top and bottom. Now look at your smaller fraction. Can that one be reduced more? Because what we're doing is we are taking out a crazy form of 1. So back up here, I was multiplying by the crazy form of 1. Down here, I'm seeing if there is a crazy form of 1 in there, and if there is, I pull it out and get rid of it. So to reduce a fraction to lowest terms, or simplify a fraction, or simplify, that is often what you'll see as directions, horribly vague, I know. Remove all factors common to both the numerator and denominator. Later on, we're going to expand, like later on being algebra, if you have to take something in the algebra sequence, the term factor actually can start to be a letter. Like if you peek at 26 and 27, we have x's and exponents, even though we haven't talked about exponents because that's the way our book rolls. Someday. Same idea though. If I have an x on the top and an x on the bottom, it is assumed that those must represent the same number. I don't know what the number is, but I know they better be the same. Otherwise, I would have called one of them a different letter. So like we're seeing some letters. This is just to kind of get you used to what are these letters doing. That's all they're doing. They're saying, well, I don't want to tell you what X is, but I'll tell you 72 got multiplied by one of them and 60 got multiplied by two of them. But I don't want to tell you what it is. So it could be 2, it could be 4, it could be 7. We don't know. But we know that there's 1 on top and 2 being multiplied on the bottom. So I can cancel one of them out on the top and bottom. The same way the 2 C's are the same there. So they turn into the 1. All right, so let's play with our numbers, see what we get. Now, again, if you get the good calculator, you type 28 divided by 48 equals one of two things happens. 1, poof, you get a fraction that does not look the same because this fraction can be reduced, and it gives you the most reduced fraction. Done. 2, it gives you the decimal. You then have to Google, how do I make my calculator, whatever model this is, do fraction answers? There's either a button that'll switch back and forth between like SD or FD on a lot of calculators, and it'll have like arrows in between. So try that, it'll switch. You can check the manual. You really can Google this though. It's like a very common question for calculators. It'll pop up a result pretty quick. Or bring it into office hours. I can try to help you figure it out. We can Google it together. So 28 over 48, if you're crunch, 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 chick, ding, answer. But if you're not, 28 and 48 are even. So I'm going to divide them both by 2. So 28 is the same as 2 times 14. 48 is the same as 2 times 2 and then 4. So 2 times 24. All right. So the 2 on top, 2 on the bottom, canceled. They divide into each other. 2 divided by 2 is 1. Gone. Multiplying by 1 does not change our number. So 28 over 48 is the same, is equivalent to 14 over 24. But 14 and 24 are still even. So we do it again. So 14 is 2 times 7. And 7 is prime. So this is the last time we got to do this. And then 12, 24 is 2 times 12. So again, the 2's cancel, and our reduced fraction is then 7 over 12. Now, if you're more comfy with your times tables, you might have recognized 28 is 4 times 7 and 48 is 4 times 12. And you could have started with that as your line of work, and the 4's cancel, and poof, you're at the answer. Totally works. But if you don't notice that, then we don't usually talk about the divisibility rules for 4, because you can just use the divisibility rules for 2 twice and get the same result. It's a little more work, but it's less memorizing these weird rules. All right, 15 over 24. All right, 15 doesn't have a lot. It's 3 times 5. And 24 is not divisible by 5. Is 24 divisible by 3? All right, so I'm thinking I got 3 times 5 on top. And those are both primes, so that is actually the prime factorization of 24. Done. 5 is not going into 24, but 3, 2 plus 4 is 6, does. So it is 3 what's? Well, we know 4 3s is 12, and 2 12s is 24. So that's 8 3s. That's one way to think about it. Did we just have that? Yes, we literally just had that in number 22. Silly book. All right, and those divide out to a 1. And our reduced fraction is indeed we just used it, 5/8. All right, now getting a little uglier. We can still do this though. I believe in us. So we have 72 and 60 to play with, and we have the x and the x squared I was talking about. Now remember, earlier I was saying exponents are just a shorthand because mathematicians are lazy and they don't want to write x times x times x times x times x times x times x times. They don't want to write it a whole bunch of times. They're lazy. They just want to say it's X being multiplied 7 times, or X being multiplied 12 times. Yes, they will write that sometimes. No, we don't expect you to crunch a number in there. So because the top one is a single X being multiplied and the bottom one is X times X, that is 1 on top and 1 on the bottom, will divide to be a 1. If we put a variable on the bottom of a fraction, we are implicitly saying that variable is not going to be 0, because this would be a dick question if it was, and we're not going to ask that. So we can assume that whatever X is, we're not going to get a divide by 0 error. I know that's kind of frustrating because they don't tell you, and the mathematician would prefer to write that, but it gets really tedious to write all of those little caveats on every single question. And mathematicians are lazier more than precise, so they err on the, well, they're just going to remember that. Yeah. All right, so now we just got to play with the 72 and the 60. Well, 60 is divisible by 2 and 3. So it's divisible by 6. So what about 72? It's 2. 7 plus 2 is 9. 72 is also divisible by 6. All right. So I'm just skipping up ahead. We'll probably still get another number to pull out of there, but 6 times 10 is definitely nicer to work with. And then 72, 6, and I believe that is 12. Yeah. 6 times 2 is 12, carry a 1, 60 plus 1, 70, 72. Yes, so 6 times 12 is 72 with that single X. All right, so let's cancel what we got. 6, 6, X, 1 of the X's. Now, I don't want you to see the X on top, the X squared on the bottom, and you cancel the X's and you leave that little squared, or you turn it into a 2. If you have to take any exponent and write it back out as how many things are being multiplied, do it. Eventually, you will do it enough to where you don't have to write it out anymore. But initially, I would rather you guys take that step and write it out so you are sure what you wrote is equal to what you started with. And then go from there. It's a little more writing, but fewer mistakes. Then the mistake is you may not have copied enough X's down, but at least that's a non-mathematical mistake. And I don't take off near as much points for that. They are harder to track down if you don't write all your work out, though. All right, so tentatively I have 12 over 10x, but 12 and 10 are still even. So that's going to be 2 times 6 and 2 times 5. Well, 2 times 5 times x. And our 2's cancel. Divide to 1, so we have 6 over 5x. I draw my x's with an extra little curl to them so they don't look like a times symbol, or since my handwriting is not always perfectly straight, sometimes they can kind of get tilted and then it might start to look like a plus. So I try very hard to put that little extra curl in the front of the X. Technically, it looks like the Greek letter chi. If you ever take statistics, then it gets confusing, but otherwise it's fine. So just FYI for my handwriting. All right, so there is our lowest terms, and we tackled variables and lived to tell the tale. All right, now 27. Because they're being perverse, they threw a negative in there. Guess what that does? Nothing. Just means we get a negative in our answer. So our answer is guaranteed to start with minus and then the fraction. Now I want you to look at that. I used my words, but if you look at it, it looks like I tried to draw a really big fraction bar and my pen skipped. So if you are trying to do homework on your phone, this, like if you're looking at 27 and it just looked like one fraction bar, you need to be careful because that is a minus sign in front of a fraction bar. And if you miss the minus sign, Alex is going to count it wrong. And the error message will be a little vague because this is more of a typo than a mathematical error. So be on the lookout for that. Like if you can zoom in on your phone, or really just try not to do homework on your phone if you can help it. I know sometimes you guys got to do what you got to do because you're working. It's okay. Just be on the lookout for this, because this is one of the more frustrating mistakes to make, because it's not mathematical. It is I couldn't see that was a minus. I don't want you guys to miss points for something that little. All right, so we got our minus sign. In fact, I'm going to change the color of that just so it's extra clear, and I'll kind of bold it in just in case anybody is color. You know, if anyone is colorblind, let me know, because I use a lot of colors, but if you're not seeing the colors, I can try to differentiate my colors more, so maybe you'll be able to see the difference. Just if you are, let me know if you're comfortable letting me know. All right. So our negative in front and then our fraction bar. So 16 and 12. Well, these are smaller numbers. I'm more comfortable with these guys. I know there's 4s in there. My 16 is 4 times 4 because I like my squares. My daughter watches way too many numbers videos. So number blocks. And then A times B. And then on the bottom, 12 is 4 times 3. And just times A. All right, so let's get rid of our incommons. A 4 and a 4. Boom, gone. A and an A. Boom, gone. So our leftovers start with a minus. On top, we have a 4 and a B. On the bottom, we have a 3. Now in my handwriting, my minus sign almost always tends to go a little above the line where the fraction is. So just when you're looking at my handwriting, I generally, like, unless I'm writing super fast, I will try to put that minus sign a little higher so it's a little clearer that that is not a broken giant fraction bar, but it is deliberately a minus and then a fraction. If you ever can't tell on something, ask, because I know sometimes your computer just like decides, I'm not going to render this today, especially if you use a Mac. So totally fair question. All right, just a couple of word problems. Don't freak out. I know I said that and some of y'all were like, oh God, we should be freaking out. No, just like word problems tend to cause people anxiety. Try not to freak out. These word problems, like, it's like the math and the English people both went over them and kind of came to a consensus instead of argued over it. So these are all written a little bit better. And plus, we're only asking about fractions, and we haven't done much with fractions. We haven't added them yet. So all we can really do is write it and reduce it. And we have a calculator. Not that bad. We can do it. I believe in us. I believe in you. The two-year college employs 210 mathematics professors. That is an insanely huge community college. Oh, there's more than one campus. 126 mathematics professors are employed in the South Campus of the two-year college. What fraction of the professors work at the South Campus? More than one campus, that makes more sense. I'm in San Antonio. Alamo Community Colleges is 5 community colleges. I believe we got 210 across all 5. Probably have more than that across all 5, actually, because Palo Alto and SAC are huge. But what fraction? So I need to know how many math professors there are. And they told us 210. So one math professor represents 1/210th of the total number of mathematics professors. And then how many 210ths, how many professors, single one professors do I have? I'm considering 126. So that is 126 copies of 1/210th. I'm going to write that. 126 copies of 1 that is a 210th because it's 1/210. And when we have multiple copies, remember that way early, several videos ago, fractions are the size of the fraction and the number of copies. The number of copies is the number on top. So this is actually 126 over 210. Technically, that answers the question. But if you type this on Alex, Alex will be like, yes, but you need to reduce your answer. And it doesn't actually count that as wrong. It'll give you a freebie like, oops, you forgot to reduce. So just go and reduce, and then you just keep going. It's way better than MATLAB for that. So 126 and 210. Well, I know there's 10 on the bottom, and I'm not getting 10 out of the top. I at least see they're even, so let's start with that and see what we get. So 2 goes into 12 6 times, 2 goes into 6 3 times. So 2 times 63 and 2 times 105. All right, so the 2's cancel. And again, totally fine to just crunch it on your calculator. Poof, here's the reduced fraction. So 6 and 3, 6 plus 3 is 9. So this is divisible by 3 at least, and 9, but 1 plus 5 is 6. So we are going to get 3 out of each of these. So that would be 3 times 21. And 3 times, I can get 3 3s out of 10. Taking out 9 leaves me 1 or 10, 15. So 3 times 35. All right, so the 3's cancel. Now 21 and 35. Those are obnoxious 7 numbers. 21 is 3 times 7. 35 is 5 times 7. So the 7's cancel. So they don't have to be the first numbers. They can be the second numbers, or one in front, and they can be crosswise. They don't have to be in the same vertical position. You could have one in front and one behind, or vice versa. Just as long as you're canceling the same thing on the top and bottom. Apples for apples, as it were, or oranges for oranges. So our lowest one is 3/5, because 3 is prime, so it can't reduce anymore. 5 is also prime, so it doubly cannot reduce anymore. So 126 math professors out of 210 total math professors is 3/5 of the math professors work at South Campus. So when you answer a word problem, the best thing to do is to write a sentence, or at the very least, think through what the sentence would be when you are answering. What fraction of the professors work at South Campus? 3/5 of the professors work at South Campus. And usually you just take the question and put the answer where it would make sense, and there is your sentence. Because math people are lazy. That is how we like our sentences for word problems to be written. Which is why just like writing the 3/5 right after it is like, and the answer is 3/5 to that question you asked me. Last little cute one. The chart shows the number of movies a film company produced in 5 years. Sure. What fraction of the movies was produced in the 4th year? What fraction of movies was produced in the 5th year? Okay. So earlier, we knew our part was 126, and we knew our total was 210. Here, I don't know my total, because I need to know, this is the number of movies they produced in 5 years. I wanted to know what fraction of all those 5 years was produced in the 4th year. So how would I figure out my total of all those years? But they didn't give it to me. What does total mean? So if I tell you to total something up, that does not mean go eat a bowl of old school cereal. Yes, there was a cereal named Total. So totaling hopefully triggers like figuring out how much the total costs. It's adding it all together. So to figure out our total here, all the parts that I'm including, which are all 5 years, I have to add the number of movies for each year. So we got to figure out, this is where the calculator comes in handy. Total, add. Come on. So we have clear. 16 plus 19 plus 13 plus 15 plus 12. So when I do it on the phone, can I make it see Yeah. So you can kind of see it's like a whole string of them all strung out. Some calculators will write it like this. Other calculators may just like do the total as you're pressing the numbers. So just be sure. But in this case, I hit equals and it tells me 75. So we now have our total. So there's my crazy looking 7. My 1 usually doesn't get the extra bars. My 7, I try to always put the crossbar so it doesn't look like a weird 1. So if you see the cross thing, it's probably a 7. If you don't, like back up here on the 126, there's my normal 1. Had one student ask what my handwriting was on something, and now I'm paranoid about it. So 4th year had 15 movies. 15 out of the 75, and it turns out 75. If I divide that by 5, I get 15, which is the number on top. So I'm going to be lazy. So this equals 15 over 5 times 15. So if I cancel the 15 on top and the 15 on the bottom, I am left with 5. Now pause. Does 5 make sense as an answer? What fraction of the movies was produced in the 4th year? 5. 5 technically is a fraction, but usually when they say what fraction, they want a number between 0 and 1, and 5 is way bigger. So we got a boo-boo. Look where the 5 is. It's on the bottom. So this is not 5 over 1 is equivalent to the number 5. This one, though, is blank over 5. So remember, when I keep saying, and these cancel, and I say, and 15 divided by 15 divides to 1. That's our missing placeholder here. I could have written it as 15 times 1 instead of just the 15, but I did that on purpose. So that way, if you guys make the mistake, I've at least talked about it once. So the fraction of movies in the 4th year is 1/5. So this production house made 1/5 of the movies in whatever 4th year this is. Must be something like Warner Brothers or something. All right, and then what fraction of the movies produced in the 5th year? Our 5th year has 12. No. So 12 out of 75. So over here I had 75 is 5 times 15. 15 is 3 times 5. So I'm just going to write that on the bottom. That's the same as 3 times 5 times 5. You can just write out the prime factorization, and that way you're not having to find like, what's the perfect pair with the biggest number? Just write all the prime numbers, and then you're just canceling out the prime numbers top and bottom and take the results and multiply them back. So the 12 on top would be normally 4 times 3, but I'm going to split that 4 into 2 times 2 times 3. And now we're going to cancel what is in common. So 2's on top, no 2's on the bottom. 5's on the bottom, no 5's on top. But I do have a 3 and a 3. 1 on top, 1 on bottom, so they cancel. The 2 2's are on top, so they can't cancel because it's not top and bottom. Same with the 5's. They're both on the bottom. It's not top and bottom. So now we just take our end results and multiply. 2 times 2 on top is 4. 5 times 5 on the bottom is 25. So only 4 25ths of the movies were made in the 5th year. So looking at 4 25ths versus 1/5, those are kind of weird to compare. Now look back at the bar chart. Which year produced more films? Year 4 or year 5? Reading the side of the graph saying number of movies, 15 is more than 12. So year 4 is bigger than year 5, is more movies produced than year 5. So the 1/5 we got for year 4 has to be bigger than the 4 25ths we just got for 5. Even though the number on the top and the bottom are bigger in fractions, bigger numbers on the bottom means smaller pieces. bigger number on top does mean more copies, but when the numbers are both different, it can get hairy to compare like that. So just think about what does the fraction mean when you're going to compare them, because eventually we will look at that. Okay, that is it for 2a-2. I will then record 2a-3.